Hello all. As we have already discussed 4 modules related to numerical methods and applications, let's see the last module, that is boundary value problems in ordinary and partial differential equations. Say we have 4 types in this particular module. That is, first one, 2-point linear boundary value problems using finite difference methods. In the second part, we have 2 varieties to solve a 2-dimensional equations using Laplace as well as Poisson's equations. Say we have a Laplace equation which is of the form u(x) plus u(y) is equal to 0. And for the Poisson's equation, left hand side it remains same, where on the right hand side we have a function. Coming towards a third part, which is 1-dimensional heat flow equation of the form ut is equal to c square u(x), where we have to solve that using 2 methods, that is explicit method and implicit method. In implicit method, in particular, we are supposed to use Crank-Nicolson method. And at the last, we have 1-dimensional wave equation, which is of the form utt is equal to c square u(x), and which has to be solved using explicit method. So let's see one by one, where the first method is finite difference method. Here we can see that x has to be changed by xk and y has to be changed by yk. And if we have a differential equation y dash, it has to be changed by yk plus 1 minus yk minus 1 divided by 2h, and y double dash by yk minus 1 minus 2yk plus 2yk plus 1 divided by h square, where we can see h is nothing but the limit difference value with the number of steps, that is b minus a divided by n. Okay, let's see how exactly this works out in a problem. So let's take down a mathematical problem. Solve y double dash is equal to x plus y with the boundary condition y of 0 is equal to y of 1, which is equal to 0. So this is the problem what we have going to see. Say the x, which is varying between 0 to 1, okay, with 4 numbers of steps. That means 0 to 0.25, then 0.25 to 0.5, 0.75 to 1. Okay, let's see. At the value y of 0, initial value is 0, and y of 1, the final value is 0. So intermediate values, that is y1, y2, y3, which we are supposed to calculate. So in beginning, let's calculate what is the value of h. b minus a divided by n, which we have seen earlier, which is equal to b is the final 1, it's a value, and initial it is minus 0, divided by the numbers what we have is 4 steps. So the incremental h value what we get is 0.25. Say if we take the equation y double dash is equal to x plus y, where we are supposed to replace y double dash by yk minus 1 minus 2yk plus 1 by h square, where x has to be replaced by xk and y has to be replaced by yk. So let's substitute the above equations. So we get yk minus 1 minus 2yk plus yk plus 1 by h square is equal to xk plus yk. On taking the LCM and multiplying, so what we get is yk minus 1 minus 2yk plus yk plus 1 is equal to xk plus yk whole thing multiplied by h square, where the value of h what we have calculated is 0.25. On substituting and simplifying, the equation what we have obtained is yk minus 1 minus 2.0625 yk plus yk plus 1 is equal to 0.0625 xk. Say we are supposed to calculate the values of y1, y2, y3. So we have to substitute the value of k starting from 1, and it has to be substituted by 2 as well as 3 to obtain the values of y1, y2, y3. On substituting the value of k as 1, we get the equation as y naught. Say if we substitute k is equal to 1 in the above equation, so k minus 1, that is 1 minus 1 is equal to 0. So y naught minus 2.0625, k value is 1, therefore it is y1 plus yk plus 1, where the value of k is 1, so y2 is equal to 0.0625 x1. So what is the value of y naught? Y naught is equal to 0, which is already given. So 0 minus 2.0625 y1 plus y2 is equal to 0.0625. What is the value of x1? Which is equal to 0.25. And the final first equation what we get is minus 2.0625 y1 plus y2 is equal to 0.0156. So that is first equation. Next, substituting the value of k as 2, the equation what we develop is y1 minus 2.0625 y2 plus y3 is equal to 0.0625, where the value of x2 is 0.5. On multiplying, what we get is 0.0313. So let's call that as equation number 2. On substituting the value of k is equal to 3 on the previous equation, what we have obtained is y2 minus 2.0625 y3 is equal to 0.0625 into x3, where the value of x3 is 0.75. On multiplication, what we obtained is 0.0469. So let's take it as equation number 3. On solving equation 1, 2 and 3, which is a linear system of equations with the 3 unknowns, either we can use any of the Gaussian methods to solve the linear equation. We obtain the value of y1 as minus 0.0349, y2 minus 0.0564 and y3 minus 0.05. So this is how we solve the boundary value problems using finite difference techniques. So next, the second problem. Let's see what is the difference which we can see from the first problem. So here we have a problem using a finite difference method. We are supposed to compute y of 0.5, where the equation given is y double dash minus 64y plus 10, which is equal to 0, and the boundary values what they have given is y of 0 is equal to y of 1, which is equal to 0, and we are supposed to divide that into 4 equal parts for the first case, and for the second case it is 2 equal parts. Say if I take the first case, that is 4 equal parts, which is similar to the previous problem what we have dealt. Say we are supposed to calculate what is y1, y2, y3. On simplifying and carrying out the same procedure what we have dealt in the previous problem, the values of y1, y2, y3 is 0.1287, 0.1471, 0.1287. And for the second case, that is 2 equal parts, the value of unknown is only 1, that is y1. On substituting the value of k as 1, what we get is y1 is equal to 0.1389. So this is the second problem. So on the third one, so let's see what is the change. Again, here also we are supposed to solve a boundary value problem, that is y double dash minus y is equal to 0 with the boundary values y of 0 is equal to 0 and y of 1 is equal to 1. Say taking delta x is equal to 0.25, where the delta x is nothing but the value of h. So again, this is similar to the first problem what we have dealt. Here also the number of unknowns is 3, and on using the same method, we can calculate the value of y1, y2, y3 by substituting the values of k as 1, 2 and 3.